Okay, we're going to go ahead and start with the picture program on doing piecewise functions. And so here's some samples of some exceptional pictures that were created with piecewise functions. And so yours may look like that or they might not. Um, but what we're going to do is talk about also the requirements for your project. And if you go to the second page of your packet, it's not up here on the PowerPoint, but if you go to the second page of your packet, I'm going to go ahead and read through the instructions for your graphing piecewise functions. Okay, so your assignment is to create an artistic design by following various functions, by graphing various functions. And you can use all of these different types, which we're about to talk about, all of these different functions that we have talked about. You must include at least 4 functions in your project. So, and you also want 3 of them to be different types. So perhaps you're going to include a line, a square root function, and 1 exponential. But then you have duplicates of lines. That's fine. You have multiple lines. Then that's fine. That would satisfy the requirements, the minimum requirements of the project. Your design cannot be a duplicate or an extremely close copy of another person's design. And in your program, you're going to set a square window, and that's what I'm going to demonstrate here. You also can see how to add your name and your date in the window. That has to be included. And then you're going to store your program in your calculator. And I recommend writing down your program because I've already had students who started and lost their program. Also, there's not an undo feature. So if you mess up a line and you can't remember what that, if you clear it, that line's gone. You can't retrieve it like you do on the or a computer. So if you have that program written down, then you could go look back and you could find what that was. So you're probably going to want to keep a piece of notebook paper and keep a running tally of what your program's lines are also. If you get a section done, you could upload it to my computer to save that also. We can do that. When your art is complete, then you will bring it to me and link it to the picture, my TI GraphLink program, and then we'll print that out. So the way that you're going to get grading credit is you're going to get 70 points for just having a basic picture. All right, so while your basic picture is 70 points, then each new function that you make is 5 points. So you have a draw F, and that's what I'll be looking for in your program, draw F, which I'll be showing you today. Every draw F is points. Anything else is just extra stuff to help make your picture, but it's all of the commands that are draw F that give you extra points. New functions are 5 points, repeated functions, so if the first line you have, that's 5 points, but then repeated lines after that, they're just 2 points. The highest score you can get is 105, and this is a test grade on your 6 weeks. Okay, so let's take a look at the functions page, which is what this PowerPoint is, and let's talk about what the parent functions are of these functions here, which we have studied. Almost all of them, one of them we haven't. But I want you to write down these parent functions, and of course these are what you will put in there, and you know how to shift them around or make them steeper and try to find them to fit your picture. So here we go. What would be our parent function for our linear? Y equals x. Okay. And and for our quadratic, okay, y equals x squared. Now, while we haven't spent extensive time on this one, really much time at all, our absolute value function is the absolute value of x, and what that has done, of course, is take this linear, and absolute has to be the positives, so it's taken this linear function down here and done what with it? Reflected it up there into the positives. Okay, now if you were going to put an absolute value function into your calculator, the way that actually would appear is you would have to do this ABS X. And I'm going to show you how you can get that ABS, or I'll show you where the catalog is. The catalog on your calculator is a button that I use all the time to find a function that I'm not really sure the buttons to get to it. So if there's something that you want and you can't find it, you can go to the catalog, and it's an alphabetical list of all the functions on the calculator. So that's your last resort. You can always go there. All right, and then we know our square root function well. Y is the square root of x, cubic. And we have that cubic behavior. Y equals x cubed. How about our cube root? What would that be? Okay, there is a function on there, cubed root of x, okay, but you also can write it in your calculator as y equals x to the 1/3, like that, okay? Now, this last one we actually haven't gotten to yet. It's going to be in our chapter 10. It's the reciprocal function, and it would be y equals 1 over x. I would think that this you can handle with other things, so you're probably not going to use that since you're not very familiar with that and how to move that around. Okay, got that all written down? So next, the greatest integer function. Since this project actually came from a pre-cal class, there are a couple of functions that are listed here that we haven't done yet, or aren't going to cover at all, this greatest integer function being one of them. And so we're not going to mess with that. You could just find other ways to make shape like that if you needed to. But our exponential function we have just finished talking about. So we've got y equals, and then you need some base number, and you're going to raise that to the x power. That's what's making that exponential, is because you have that x up there. You know, this would be like y equals 2 to the x, or 3 to the x, or 4 to the x, okay? And so that is going to have a different steepness based on those numbers you do there. That's a number. This would be your base number. That would be your base number out. So it's just some number like 2 to the x or 3 to the x. Okay. Now logarithmic is our inverse of this exponential. We haven't gotten there yet. We're just about to get there after tax. And so we've got y equals log x is how you would do that if you were trying to find that. Okay. These next three are trig functions. Those are ones that you would do in pre-cal. But you might want a squiggly line or a wave. So I'm going to tell you how to do these, since you might want that type of thing in your picture. We found that our calculator actually has to be in radians to make our lines show up. So I can demonstrate that. We'll hopefully get this in, and we'll practice putting in a squiggly line. But we would put this in as y equals sine x. And of course, this would the parent function of this would be y equals cosine x, and that one's y equals tangent x, or tan x. But let's talk about this semicircle. This semicircle is a chapter that I'm not getting to, and I'm so sad that we're not getting to. I think we spent too much time doing applications at the beginning, and we're not getting to this. So, but you do need to know in its most basic form how we're going to do this. A circle equation is x squared plus y squared equals r squared in its parent function form. But you know, when we put things into our calculator, they have to be solved for y. So how would I solve this for y? Okay, get y by itself, so I'm going to subtract x squared. So write this down. So y squared is equaling r squared minus x squared. Now what? Square root. Okay, so y equals the square root of r squared minus x squared. So this is the parent function that would give us the top half of a circle. Why is it going to give us the positive top half of the circle? Because when you just write it like that, when you're taking the square root, unless you put a minus sign in front, it won't give you the bottom half. So if you wanted the bottom half, you would have to put y equals negative square root of r squared minus x squared. Okay, now I think I had written on your paper an equation, and I was careless and I miscounted, or I just wasn't thinking right when it clearly whenever I put that equation down. So the one I put down is wrong. It is not actually the square root of 16 minus x squared. It's 4 minus x squared. Take a look at this picture and tell me what was my mistake. I'm supposed to do the radius squared, and the radius is 2. So 2 squared is 4. But I boo-booed when I hastily put that equation down, and I put 16 instead. What was I calculating? I did the whole diameter. Okay, but you want the radius there. Now, if you were shifting this left and right, of course, you would have parentheses here, and underneath the radical, you'd have your h. Outside, you'd have your k. And remember, h's are always doing the opposite direction of what we think. Okay, we are very well versed in our transformations of our parent functions. The k values are doing a what? A vertical shift. So this k value is a vertical shift. This h value is a horizontal shift. And remember, you just told me it's going to be the opposite. Yes. That would be y equals tan x. Tangent would be y equals tan x. That's okay. That's okay. You're right. I didn't specifically do that. Okay, so when our a value here is greater than 1, what's it going to do to the function? Stretch it. When our a value is less than 1, it's going to compress it, or as listed here, vertically shrink it. And then look at our reflections. We know this one. This negative here is going to take our function and reflect it over the x-axis, but to reflect it over the y-axis, you have that negative inside. Okay, so that's the end of the PowerPoint. And so what I want to do right now is go ahead and take a look at the papers that we have and explain to you what's going on with this. So go to your packet now. Okay. Now, let me just tell you and be honest with you here. The first time I did this, or the way I learned how to do this program, was by just reading these instructions. They are very clear. They are very specifically told to you. So to start the program, look right here on your packet, all of these buttons are the pictures of the buttons that you push. So if you are good at following directions, then you could do this whole program without me sitting here blabbing and talking you through it. But I'll go ahead and show you where some of the things are on the calculator if you get lost. So we're going to start here, and I'm just going to follow straight through this. We're going to hit Program, right arrow, Enter. And we have already made sure that our calculators were enabled. You can name your program whatever you want. You can name it Practice. You could name it your name. Whatever way you could easily identify your program. Okay, so, all right, so I just put in some buttons. Hit Enter, and then that names it. So that program is now there. There is no save button that you hit. It's just automatically saved. So if you accidentally delete a line, then that's gone. You can't retrieve a previously saved version of it or anything like that. Okay, so we're first going to start off by clearing out everything and setting a blank screen to start our picture on. This is going to be the same on everybody's program. So we're first going to actually want to add one in here. I want to turn our plots off since we've been dealing with some plots. I want to turn our plots off, so let's do that first. Hit second y equals number 4. And that turns your plots off. Now hit Enter to go to the next one. Now I'm here, and right here now I'm starting with these instructions. We're going to clear the home, program, right arrow, 8, enter. So I did this right here, program, right arrow, 8, enter. And now I have clear home. Okay, the next one I'm going to clear draw. So I'm here now in this next second panel. Second program, 1, enter. So clear draw. So that's clearing out any other previous drawing that's in there, any other previous points, any other previous version that you had in there. I had a student earlier today that had a earlier mistake, and then he forgot this clear draw. So every time he tried to fix it, he kept seeing the old thing and he couldn't figure out why. It's because the old one wasn't clearing out. What? Right here. Second program 1, enter. Okay, next, second zoom, arrow down to turn the grid off. Hit enter. Enter again to get down to the next line. Okay. The grid is, if you have, a graphing grid up there, sometimes some people turn on the graphing grid. So if it's up there, then that command turns it off. Now we're going to turn the axes off. So your x-axis and your y-axis, so that your picture is showing up on a clear screen, and that's right here. Second zoom, arrow down, over, enter, enter. So second zoom, arrow down, arrow over to axis off, enter, enter. Okay, so that's all the basic clearing your screen things. Now you can turn the page. Okay. You can turn the page. Oh, nope, never mind. I didn't want to do that. I'll be right there to help you with that clear draw. Turn the page, and then you're over there to that set your square window. So let's do that next. Okay, so if you end up needing to, if you have two things on a line, that's fine. They just have to be separated by colons. And the colon is down there above the decimal point. So if for some reason you accidentally you didn't press enter at the end of a line, and you have two commands on a line, you can then just go back up there and put the colon in between them, and then that's acceptable. Okay, but let's do this square window. Up here, this paragraph at the top about this square window is just describing how your calculator has more pixels one direction than the other. So we want to square it off so that your pictures show up in the correct proportion. So here's how you do that. First, we're going to define our x-min and then our x-max. Then we'll define our y-min and our y-max. So right here, we're going to just use these button commands, and we're going to do negative 4.7 times 5. Store. Store is located above the on button. Store. And then vars. Vars is located right here beside the clear. 1, 1. Because 1 is x minimum, enter. Okay, so I defined the window. I'm defining my window as that value for my x minimum. Okay, now do that for your x maximum, which is a positive 4.7 times 5. Store. Vars. 1, and then 2 is x max. Enter. So you make sure you're entering a command on the next line. Yeah, so your first one should say x min, the next one should say x max. Okay, now we're going to do the y's. negative 3.1 times x store vars. I said times x, I meant times 5, didn't I? 1, and then what's the y min? 4, enter. Okay, so it should look like, now, there's a mistake here actually on this picture of your page. The points are noted correct, all of these buttons are written correctly, but this picture is not written correctly. This says just negative 3.1 is the y minimum, and it's supposed to be negative 3.1 times 5 is the y minimum. Now, it shows up correctly here in this next frame, but it was just not printed or not screen captured correctly on that one. Questions there? Okay, so let's do our last one. Our y max is going to be 3.1 times 5. Store vars 1, 5, enter. Okay, so we are done setting square window. We're done clearing everything out. Every single program will have those commands at the beginning. So those are the same for everybody's. Any questions there? All right, what we're going to do now is actually do some sample um, parts of a picture. We're going to put in a piece of a parabola and a point and a line. And so since this stuff that you have up here at the top is going to be the same on every single program, but this next stuff is just going to be kind of some practice stuff that you might, some practice junk that you might want to go back and delete out when you start doing your real picture. Why don't you skip some lines? Hit enter several times so that you know that you're starting the sample stuff that you're going to go back later and delete when you start your real picture. Okay? So I just skipped some lines for you to know this is the sample practice stuff. Okay. So the things that we're going to practice are these right here. We're going to practice entering a function, a line. We're going to practice entering a function, lines, points, and text. So here's how you do that. Okay, the first thing we're going to do is a function. These are the ones you get points for. These are the ones you get points for. So we're going to do second program because that gets us to draw. So second program, and look down there at number 6. That's draw F. That means you're commanding it, the program, to draw a function. So hit 6, and that's what I'll be looking for and scanning for to give you points on your program printout. So draw F, and then we're going to put in the function x squared plus 3. So what kind of function is that? It's a quadratic. Don't hit enter at this time. Well, you know what? Let's do that. That's fine. We can hit enter. Okay. Hit enter. That's fine. Hit enter. You want to go see what that looks like? You want to see how to execute your program and play your program? The way to do that is to go second, quit. Now go program, and up here at the top it's executing. You find your program you're going to execute, hit enter twice, and it'll execute it. And there's the parabola that we drew, that we put in there. Okay, so after making sure that you can get that up there, now let's go back and edit that function. Maybe you only want a piece of that function to show up. Maybe the only part of this function that you want to show up is from -1 to this 2 value. And a way you can find out where that is if you just hit the up arrow, a cursor will appear and you can go on that function and you can go, oh, okay, Look, I'm looking at my x value because I'm going to define my domain. Maybe I want it to be from there, from that part of the parabola, so that's an x value of -1, and I want the little smirky smile, so I want to go to there. So maybe I want to go from -1 to 2, and that will give me a little piece of my parabola. All right, so now let's go back to our program. The way you go back to your program is Program. And what are we going to do with our program? Edit. So go over to Edit and hit Enter. Go down. Don't start typing right there, or else you'll delete something out that. So go down to where we are. We were on this draw function. I only want part of that function. So I'm going to define my domain that I want. And here's how you do that. It's right here. Here's where this is. You might want to like highlight this line right here in your packet, because this is where it shows you how to define a particular domain. So that's where it shows you the particular domain that you want. Okay, so that's where we are in the packet. All right, so let's do that. So if I want to define this domain, I'm going to hit the division sign. So that's kind of like a such that. So here's my function, x squared plus 3, and then I'm going to tell you what the domain is. Parentheses to open my definition of my domain. Now I want my domain to have two parts. I want another parentheses, so I do x's that are greater than -1. Oh, if you look here in these buttons that they describe here, the greater than is going to be under second math. Second math right there. Okay, so I'm going to go second math greater than is number 3, and I'm doing greater than -1. Close that command. So that was the first piece of my domain command. Now I have a second piece. I just have one parentheses there because now I'm going to open up another one. And so that one was x's are greater than -1. So what's this next one going to be? X's are now going to be less than. So less than is under second math. 5. Oh, I didn't put my x's. X is less than 2. Close that command, but now close the entire domain command. So I have two parentheses at the beginning and two parentheses at the end. See, because here's what happens. Those two blue parentheses line up together to make one command. These green ones line up together to make the other command. And then these red ones were the whole entire thing. Okay? All right. So let's go see what that did. So, enter. Second quit. Go execute your program and see if you now have a piece of your parabola. Okay, so check that. The next thing that I want to have you guys do is put in a point. You might have like some raindrops or something or other, I don't know, something that you need to put a particular point. So here's where we are in your packet. You can draw points in your picture, so we're going to do those commands right there. Here we go. Go back to your program and edit it. Go down. Don't start typing there on top of your other stuff. Go down. And I'm going to put in a point. The point is, I go second program. See, I'm going to arrow to the right to where it says points. And I have options. I can turn points on. I could also turn points off. So if, say, I had a function and I just wanted to have a little hole in the middle of it, I could turn those points off that way. Or I could have defined my domain, but here's a point on. Hit enter. Now, what do you think these two numbers are going to be representative of here? They are the coordinate of the points. So let's put our point at the coordinate 6, 3. Okay? Which, by the way, I will give you some information. The left side of your window is at negative 23 and a half or something like that. The right side of your picture is all the way up at 23.5. The top of your window is at 15.5, and the bottom of your window is at negative 15.5. So if you had a point in there that was bigger than those numbers or outside of that window, then it wouldn't show up. Okay, so do you want to go see that point? Quit, execute your program, see if your point is showing up next to your little piece of your parabola. There it is. Okay, now the next step we're going to do is put in a vertical line, and that is right here in your, that's right here in your packet. Okay, we're going to put in a vertical line. These vertical and horizontal lines do not count as points for you. Only draw F's count as points. But you still might need these lines to connect things or make pictures. So let's put that in. So go edit your program. Go down. Okay. So to do a line, I'm going to go second program. Where do you think I'm going to go? Number two. Number 2. Okay. Now, I want you to put in these numbers and then I'll explain to you what these are. Negative 3, comma, 4, comma, negative 3, comma, 1. Close your parentheses. Hit enter so you get your next command colon. Okay, let me tell you what these are. These first 2 numbers represent the starting point of your line. Oh, okay. Okay. All right, I'll go fix it. It was supposed to be a negative 1. Okay, so I'm going to insert in a negative there. Okay. So there we go. So once again, these first 2 numbers represent the coordinate of your starting point of your line. The second 2 numbers represent the coordinate of the end of your line. Okay, so could you make all of your lines with this feature? Yeah, technically, but you won't get points unless it's a draw F line. Okay, so let's go see what it looks like. Draw F is second draw, number 6, if you want to do that. Okay, so look, you should have that by now. Okay, let's go put in a couple things that aren't in this packet, just to see if you want to do that. So let's go put in a couple other things we might want to have in our picture. Go down. Okay, what you want to put in? How about a wavy line? You want to try putting in a wavy line? Okay, so let's do function. It's a function. So if it's a function, what do I have to have first? Draw F. So second program, number 6, that's my draw F. So I'm going to do a sine function. Sine, let's just do a basic one, sine x. Okay. At the same time, let me show you how to do a let's do a semicircle. We'll do a semicircle. Okay, so hit enter and let's do a semicircle and then we'll go look at both of them. Okay, so let's do that semicircle that I had in the packet. Is that going to be a draw function? Yes, it is. It is a function, so draw F. And it was the square, if you look back at your packet, it was the square root of, I think it had a radius of 2. So that was radius squared is 4 minus x squared, close it. Now, by looking at that function, where is the center of that semicircle going to be? At the origin, 0, 0, good. Let's go look at that, and then we'll come back and move it here in a second. Okay. So let's go execute our program. Let's see, there's our piece of a parabola. There's our sine function. And then you could play around with the numbers since we haven't dealt with those signs. Um, okay, if yours is not squiggly, it's because yours is in degrees instead of radians. And so here's how you can fix that. So here's how you fix that. Let's quit. Quit. Go to mode right here. You need to make sure that yours says radians and not degrees. But turn it back for tax. You're going to want to turn it back to degrees for tax. But anyway, there's radians. Okay? Now, put it into radians and then go execute your program and see if it now is a squiggly line. Okay? And my semicircle isn't showing up. Oh, there it is. There's my little semicircle right there. I want to move it out of that mess. Let's move it up. How do I move my semicircle up? Change what? K. Where is the K value on my semicircle function? Outside the parentheses. So let's move it up 6. I don't know. I just picked 6. And then let's go look at it. So yes, it's plus 6. There it is. Oh, look, that was nice. It kind of connected to my other little parabola there. Okay. So remember that when you are defining your domain, you could say you wanted to just have a piece of that sine function. At this point, you can hit your arrow and then you can go say, oh, I want the part of this sine function from negative 8.5 to -3. Okay. And then you could go define that domain. All right. Let me show you how to do a full circle. So go back. Let's do a full circle. Go edit. Of course, you could do the negative part of the semicircle, and it would give you a full circle. Here is a way you can do a nice circle, and it's pretty easy. It doesn't give you any points, though, because it's not as a function. So here it is. Hit enter. Make sure you have a colon before you start entering in this function or this process. Okay. Just a couple more things. Here's circle. Go under draw. So second draw. Go down and look at number 9. Draw is above program. Okay. See circle there? Number 9 is circle. So hit number 9. Enter. Okay. You're going to put 3 numbers in here. The first 2 numbers are the coordinate of the middle of the circle. Where do you want to put the middle of the circle? Where do you want to put the circle? Let's pretend like it's like wheels of a car. I'm going to do it way over to the left and down. So I'm going to put it at like -7, -10. Okay, so that's the XY coordinates of my center of my circle. Then you need to do another comma, and this is now going to be the radius of the circle. What do you want to do? What size wheel do you want? No, just, yeah, 25 would be way too big. 8 would probably be borderline too big. Let's do 5. I don't know. We'll see if it fits. Close that parentheses. Hit enter. Okay, quit and execute it. Let's see where it is. There's my squiggly. Here comes my semicircle. And oh, there's my circle. See, I might wanted to move it over some more to the left. So then I would change my -7. Okay. One last bit of advice. When I was making my program, the way that I did my program, so I didn't have to keep. Okay, one last bit of advice, and this is the way that I had made my picture. I wanted to try out a function. So say maybe I knew I wanted um, a, I don't know, this was going to be, I wanted something coming off this circle. Maybe I wanted a line coming off, or a square root function coming off of this circle. So I'm going to try it out and test it out in y equals. So maybe I'm going to make this circle into a fish or something. And so I'm going to go and I'm going to say I want a square root function in there. So square root of x. But I'm pretty sure I need it shifted down already. So I think I need it down at probably like negative 5 because we said the radius was 5. And, oh, I think I also needed it shifted over. So I'm going to insert, you know, I don't know. Which way would get it to go left? Which h value would get it to go left? Positive. So if I do positive 3, okay. So I'm going to put a square root function. It's going to go left 3 and down 5. So I'm going to now graph this and see if it's where I want it. It's going to do my see, there's my y equals showing up, but it's not in my program. It's just a sample. It's just I'm trying it out. See, I was actually pretty close. This square root function right here that I had in my y equals was almost where I wanted it. And then, so I'm probably going to shift it a little bit left, and then I can do my arrows and kind of trace and say, okay, I want it to go to about 2. So I want it to go from, negative 3.5 to 2. Once I figure out what I want, then I'll go and put it in my program. So I'm going to use my y equals as my sample and try it out. And then once I got it figured out, I'll go put it in my program. I think that's an easier way to sample things out. All right, last bit of information. I never told you guys where catalog is, and that's a good place to find all the stuff if you can't remember anything, anywhere the buttons are. Second 0 is the catalog. And there's absolute value, so that's how you can make an absolute value shape. So there's all of the different things, and if you wanted something, say if you wanted something in the W's, you just would hit the W button. I hit the Q. I hit the Q's, and so there it gave me the Q's. Or if I wanted something in the C's, then it's going to give me those things. So that's a way to find something if you can't figure out where it is. Second 0, it's this, see right here, down here at the bottom, it's catalog. Catalog. So catalog